Hello, so today we're going to talk about how to solve a system of linear equations using the substitution method. When we talk about a system of equations, there's generally two main methods you can use to solve: substitution and elimination, which we'll go over in another video. Technically, you also can graph them, because when we talk about the system of equations, we're talking about solutions where the two lines intersect. So if you had a nice graphing calculator or a computer program, if you graph the two equations, the point where they intersect at would represent the solution. So to solve it by substitution, we replace the variable in the first equation with the variable from the second equation. Pretty much this means you're going to have like y equals 2x plus 3. You replace your y variable with the 2x plus 3. It gives you only a single equation with one variable. You solve for that one, plug it back in to get to the other one. Alright, so that will make a little more sense when we actually try out a couple examples. So right here, we have y equals 2x plus 1, and 3x plus y equals negative 9. So we see that y equals this 2x plus 1. So we're going to replace the y in that equation with 2x plus 1. So the second equation becomes 3x plus 2x plus 1 equals negative 9. And again, we were able to do this because the original equation was 3x plus y. And since y is the same thing as 2x plus 1, we replace the y with the 2x plus 1. So this becomes 5x plus 1 equals negative 9. We subtract the 1 to get 5x equals negative 10. Divide by 5 to get x equals negative 2. The important thing is to always make sure you remember that once you have the one variable, you need to plug it back in to get to the other one. We can plug into any equation, but since we know y equals 2x plus 1, generally, a lot easier to simply plug it into that particular equation and work it out. So we'll get y to equal negative 3. So this means if we were to actually graph this, we'll find that they intersect at the coordinate point negative 2, negative 3. So you're welcome to box the individual answers for something like this, or you can write your answer into coordinate point form. Either one is perfectly fine. So this is what it means to solve a system by substitution. We replace the variable with the given expression. It doesn't have to just simply be y equals. It could easily be an x equals. Still the same idea. Since x equals 3y minus 2, we will replace the x in the second equation with the expression 3y minus 2. So it becomes 3y minus 2 minus 4y equals negative 3. So since we have two y expressions, we just combine like terms. We get negative y minus 2 equals negative 3. And then when we add 2 to both sides, again, negative y equals negative 1. So that means y has to be positive 1. And once we have, again, y, we plug it back in to solve for x. 3 times 1 minus 2. And we get 3 minus 2, which means x is also positive 1. So again, coordinate point form, it would just be 1 comma 1. So that's the general idea behind solving a system with the substitution method. We're replacing the variable with a given expression for what it's equal to. Now, when we do this, we might have a situation where there's a coefficient in front of the variable, like it's 3y. Doesn't matter. We still write it out as 3x plus 3, and since we know y equals 5x minus 8, that's where we'll put in the place of the y. So it's 3 times the 5x minus 8. Because again, we're dealing with a system of equations, so we have like terms to deal with. So we distribute the 3 to get 3x plus 15x minus 24 equals negative 6. When we combine like terms, it becomes 18x minus 24 equal to negative 6. We will add 24 to both sides, get 18x equals 18, so x equals positive 1. Well, we plug that back in. 5 times 1 minus 8 gives us 5 minus 8, which is negative 3. So again, we're just using the substitution method. We're replacing the variable with the expression it's equivalent to. That's why y got replaced by the 5x minus the 8. Always need to make sure you're careful when you're solving these expressions out, especially when it's just minus the variable. You want to think of this as not just minus y, but as negative 1y. Because if you think of it as negative 1y, when we replace the y expression, we'll make sure we distribute correctly. It's really negative 1 times the y expression, 2x minus 3. So by doing it like this, we will distribute the -1 to both the 2x and the -3. So we get 2x minus 2x plus 3 equal to -3. And we combine like terms on the left-hand side, 2x's cancel, leaving 3 equal to -3. As we saw earlier with our linear equations, we have a variables cancel and a false statement is left over. This means it's no solution. And no solution, because again, if you think about the previous problems, the solution was the intersection point of the two lines. The no solution case occurs when the two lines are parallel, because parallel lines never intersect, and that would imply that there is no solution to their system. So this can happen. Watch out for that. Again, no solution is totally different from getting like x equals 0. That's a number, that's okay. But if the variables cancel, leaving a false statement, it's no solution. If they cancel and leave a true statement, then it's all real numbers, similar to what we saw with the linear equations. That's why it's so important to think of this as -1y, because if we didn't distribute the -1 to the -3 as well, we would have had -3 equals -3. Like if you wrote it like this, 2x minus 2x minus 3, and forgot that it's supposed to be minus the entire expression, so it's -1 to the entire expression. So be very careful when you have cases of subtraction and there's no number in front. Like if that was -2y, you're generally not going to make that mistake because you can do -2 times the expression. Alright, so that's substitution. So next video is going to focus on elimination. So I'll see you for that video.